Should we already be preparing for the end of the world? Or do we still have time to breathe? Imagine there's a monster sleeping under Siberia, a geological force that once triggered the greatest extinction in Earth's history. And guess what? It might still be awake. This is the Siberian mantle plume, a colossal upwelling of magma from deep inside the planet. Professor Egon Chalakian from Harvard University has raised serious concerns. According to him, the mantle plume under Siberia is not just theoretical, it's rising right now. He warns of a looming geological crisis that could impact the entire planet. A super eruption, he says, could eject enough ash to block sunlight globally, plunging us into a volcanic winter. His prediction? The year 2036. That's not in some distant geological future. That's barely a decade away. Chalakian is urging immediate global cooperation to monitor and prepare. But others are more skeptical. Some geologists argue that mantle plumes rise on timescales of millions of years, not decades. According to this view, even if the plume is active, the chances of an imminent eruption in our lifetime remain extremely low. So which is it? Do we have centuries, decades, or are we already counting down the final years? So what is a mantle plume? A mantle plume is like Earth's internal chimney, a column of super hot rock rising from around 2,900 kilometers deep in the mantle. These plumes are behind some of the most extreme volcanic events in Earth's history. Think of them as pressure cookers. When one breaks through the crust, it can reshape entire continents. The Siberian plume is one of the largest ever discovered. Scientists believe it's what gave rise to the Siberian traps, a massive ancient volcanic region spanning over 2 million square kilometers. To give you some scale, the estimated magma chamber beneath the Siberian plume was about 10 times larger than the one under Yellowstone. 10 times bigger. So how do mantle plumes form? Most known mantle anomalies begin in the D layer, that thin but critical boundary between the outer core and the lower mantle. This zone experiences an extreme heat gradient. Like any layered fluid system with a sharp thermocline, instabilities develop here. Some of these hot spots bubble up, breaking through as full-fledged plumes. Another hypothesis says plumes can also emerge when tectonic plates merge into a supercontinent, trapping internal heat. With no escape, temperatures and pressure build underneath. Eventually, a plume forms, punches through the crust, breaks apart the supercontinent, and keeps churning for hundreds of millions, sometimes up to 1 billion years. 252 million years ago, this beast awoke. The result? The Permian-Triassic extinction, or simply the Great Dying. The eruption lasted for nearly 1 million years, unleashing up to 5 million cubic kilometers of lava. But the real killer wasn't lava, it was gas. Carbon dioxide, methane, sulfur dioxide. These gases sent the climate into chaos. Global temperatures soared by more than 10 degrees Celsius, oceans became acidic, and oxygen levels plummeted. End result? 96% of marine species and 70% of land species vanished. It was the deadliest extinction event in Earth's history. Is it still active today? Modern geophysical studies show that the Siberian plume is still lurking beneath the surface. Seismic tomography reveals zones where waves slow down, a sign of extreme heat. Some chemical traces in nearby volcanic rocks hint that the plume's mantle source is still simmering. It hasn't broken through the crust recently, but it's not dead, it's just waiting. So what is the worst-case scenario? Imagine this. It begins with a tremor, not on the surface, but in the data. A slight rise in thermal flux, a whisper from the deep. Months pass, then years, and suddenly the ground begins to bleed gas. CO2, SO2, methane. The skies turn hazy, sunlight dims. Global temperatures spike by 6, maybe 8 degrees. The Arctic melts. Coastal cities like New York, Shanghai, and Mumbai flood, not in centuries, but decades. Crops fail across continents. Wheat doesn't grow in Kansas. Rice withers in Southeast Asia. Global food systems collapse. The price of bread rises 1,000%. Superpowers impose export bans. Countries turn inward. Wars break out over clean water and arable land. But this isn't a movie. Today, we've built our entire civilization on a geological time bomb. The question isn't if we can survive the heat, it's whether we can survive each other when it begins. Why mantle plume is uniquely dangerous. They're not sudden explosions. They're slow-motion planet changers. They can last for millennia, alter the atmosphere, spark chain reactions in ecosystems, and disrupt Earth's climate systems on a massive scale. A single plume can outgas more greenhouse gases than all of humanity combined. Over and over for centuries. You can't evacuate from that. You can only try to survive the consequences. This isn't an eruption, it's a planetary reboot button, and it might already be pressed. Can we predict it? Tracking a monster 2,000 kilometers beneath your feet? Not easy. It's not like a volcano you can watch. No smoke, no quakes, just silence. But silence can be broken if you know where to listen. Seismologists use global arrays of sensors to track how earthquake waves travel through the planet. When those waves slow down or bend unexpectedly, it can signal hot, rising rock, like the plume beneath Siberia. Then there's satellite gravimetry, measuring tiny fluctuations in Earth's gravity field. A plume changes density deep below. Gravity shifts slightly. It's like watching a ghost change the weight of a continent. Magnetotelluric imaging taps into natural electric and magnetic fields. As they pass through Earth, their signal shifts depending on temperature, rock type, and fluid content. The result? A fuzzy X-ray of what's brewing underground. Geochemists analyze volcanic rocks for rare isotopes like helium-3, a deep mantle fingerprint. If it's there, the plume is still feeding fresh material toward the crust. None of these tools give a precise date, but together they form a picture. And that picture is getting hotter. It's not about predicting an explosion tomorrow. It's about watching a slow-motion event that could define the next 1,000 years. The Siberian plume already ended the world once. If it stirs again, will we see it coming? And more importantly, will we be ready? If you're into the deep, hidden forces that shape our planet, from the Earth's core to the edge of space, hit that subscribe button.